In this lesson, we're going to learn how to use a linear model. Once you've written a linear model, like we've learned in the previous lessons, how can we use it? Of what use can it be to us? Well, one way that we can use a linear model is to draw conclusions in certain scenarios. Let's illustrate this through an example. In the first exercise, the cost to ride in a taxi cab is given by the function c of m equals 1.25m plus 4.25. They tell us that c is the cost of riding in the taxi cab for m miles, and we want to answer some questions. First, before we can do that, we have to understand the model that we have. Here's the equation, and they tell us that c is the cost of riding in the taxi. They also tell us that m is the number of miles. In problems like this, they're going to give you one of two pieces of information. In this case, they'll either give you the number of miles and ask you what the total cost would be for riding in the taxi, or they'll tell you what the cost of riding in the taxi was, and they'll ask you to determine the number of miles. Let's look at an example of each. Finn wants to take the taxi cab to a destination that is 12 miles away. Use your equation to determine the total cost that Finn will pay. Here, they tell us that Finn wants to travel 12 miles. We'll use our equation, and since the number they gave us is 12 miles, and we know from our earlier work that m represents the number of miles, what we're going to do is substitute the 12 in place of m. Now we'll simply evaluate. 1.25 times 12 is 15, plus 4.25 is 19.25. C equals 19.25. And since C represents the cost of riding in the taxi, we can conclude that the cost to travel 12 miles is $19.25. We could evaluate the cost for any number of miles traveled by substituting the number of miles in place of m in the equation and then evaluating. In the next part of our problem, we have Madeline. Madeline paid $41.75 for a trip she took in the taxi cab. Use the equation to determine the number of miles that she traveled. The information given to us is that she paid $41.75. This is the total amount that she paid for the trip. And since we know that the variable c represents the total cost, we can substitute $41.75 in place of c, and then solve the equation for m in order to determine the number of miles that she must have traveled. We begin by subtracting $4.25 from each side, and then divide each side by $1.25, or 1.25. 30 equals m, and since m represents the number of miles, we can conclude that Madeline traveled 30 miles in order to have a total bill of $41.75. Similarly, we could determine the length of any trip if we knew the total cost. Simply substitute the total cost in place of c, and then solve to find the number of miles traveled. This is how we can use a linear model. The next exercise is for you to try. Omer inherited an antique ring from his grandmother. The value of the ring is given by the function v of t equals 100t plus 4,100, where v is the value of the ring and t is the number of years since he inherited it. First, write down the equation and then identify the variables v and t and label them with what they represent. Then answer the two questions below. First, if Omer has the ring for 25 years, what will its value be? And second, how many years will it take for the ring to be worth $6,000? Please pause the video here to try this example and come back when you're ready to check your answer. Let's compare answers. The equation is v equals 100t plus 4,100. V represents the value of the ring. T represents the number of years. In the first part, Omer has the ring for 25 years. This is T, which represents the number of years since the ring was inherited. So we will substitute the number 25 in place of T, and then we evaluate. 100 times 25 plus 4,100 is 6,600. V equals 6,600, and since V is the value of the ring, we can conclude that the value of the ring is $6,600. In the next part of this problem, we want to know how many years it will take for the ring to be worth $6,000. We have our equation, and we know that V represents the value of the ring. Therefore, we will substitute 6,000 in place of V. We'll then solve the equation using our inverse operations in order to find the value of T. 19 equals T. And since T represents the number of years, we can conclude that it will take 19 years for the ring to be worth $6,000. This is everything you need to know to get started working with using linear models. You can learn more about linear modeling in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.